Also forgot to make a video on this one. Sorry. Hey everybody. Let's go over the angle, sum, and difference formulas for tangent. So this is the tangent of a plus b and tangent of a minus b. So hopefully you see where this is heading. Now, it's not some geometric proof, because we can use one of our the quotient identity for tangent, right? Because we know that tangent of something equals to sine of that something over cosine of that something. So we can apply that same principle here. In this case, let's start with that something being a plus b. So tangent of that a plus b equals sine of that a plus b over cosine of that a plus b. And you know what? I don't think I've even proven the quotient identity on this one. I'm just gonna prove it right here anyway. It's so easy, right? We know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Multiply by the reciprocal, so we get opposite over hypotenuse times hypotenuse over adjacent. The hypotenuses cancel, and then we get opposite over adjacent, and then that right there is tangent, right? Opposite over adjacent is the definition for tangent. So that's why it works. So now we know sine of a plus b, and we know cosine of a plus b, because we proved them. So we can rewrite it as sine a, and again, I know I keep saying it. If you watch the other videos, please watch the proof on the sum and difference formulas for, watch the proofs for the formulas that I'm about to use here. Because it's very important that you already understand those, because we're going to keep moving forward, and I want to make sure we have the foundations in place. So this will be sine a cosine of b plus cosine of a sine of b, and this is over cosine of a cosine of b minus sine of a sine of b. So now we're going to want to do a little bit of manipulation here. And I'm going to erase this just for some more space. Give me 1 second here. So we're going to want to multiply the numerator and the denominator by 1 over cosine A cosine B. Right? This is completely valid property of fractions, right? What we multiply with the numerator, we multiply with the denominator, and that converse is true. So if we do this here, we distribute a property here. Again, I'm just going to write out the distribution, because why not? Do it to this, do it to this, do it to this, do it to this, and then we get sine of A cosine of B, that then over cosine of A cosine of B, and then plus cosine of a sine of b over cosine of a cosine of b, and then that over then cosine of a cosine of b over cosine of a cosine of b, then plus cosine of a sine b over cosine A cosine B. So now we really just need to look at, like lots of stuff is going to cancel out. So this may be like your dream here, because you love to cancel things out. Let's first cancel the things that cancel. So we see that cosine B that cancels, cosine A that cancels. Beautiful. This entire thing cancels. This does this cancel? What is this? I think I wrote that wrong. Side. This should be sorry, you had messed something up. Sine A sine B. Should be sine A sine B. Okay, and nothing here should cancel. So I'm just going to rewrite it here as sine of A. And again, you probably can do this in your head. I'm just going to write it out for those who are not yet aware of, the things that we can do after this, which is just applying some identities. So then that over 1 plus sine A sine B over cosine A cosine B. So here, of course, this will just be, sine of A over cosine A. We just went over that quotient identity, so that's just tangent of A. Again, sine B over cosine B, that's just tangent of B. Again, went over that. And then here, I'm going to rewrite it as sine of A over cosine of A times sine of B over cosine of B, completely valid. And then this will, of course, be tangent of A, tangent of B. So we can say then, therefore, tangent of A plus B equals tangent of A. I'm sorry, that looks like a does not equals or integer symbol. Tangent of A plus tangent of B over 1. So that'd be plus. It should be 1 minus. Uh-oh. What do we do here? Shouldn't be canceling. This should be minus. Sorry. I knew something was odd. Again, lots of work, so I'm not that disappointed. At least I caught it. Imagine if I went on with the plus. No, because the reason why is because the cosine sum formula is with the negative sign. Again, the signs flip-flop, okay? Good way to remember that. So 1 minus, and then this would be tan A, tan B. Great. So now, very, very similar process for the difference formula. So tangent of A minus B, right? That's just sine of A minus B. Now the something is A minus B, so over cosine of A minus B. Let's hope I don't mess up these formulas. I got it. I proved it with you guys. So this should be sine A cosine B minus cosine A sine B over cosine A cosine B. Think I'm going to mess this up? Of course not, right? Plus sine A sine B. So now we're going to do the same thing. Multiply by 1 over cosine A cosine B, numerator and denominator, cosine A cosine B. I'm going to draw the distribution here. Again, want to make sure we're really solid with the algebra. So then we'll get sine of A cosine of B over cosine of A cosine of B minus cosine of A sine of B over cosine of A cosine of B over cosine of A cosine of B over cosine of A cosine of B plus sine of A sine of B over cosine of A cosine of B. So now canceling still going to happen here, yada yada yada. And again, I probably didn't even need to do the tangent of A minus B. You could probably see what's happening already. You probably wouldn't need to do this proof once you know the sum, because you'll understand just naturally, because of that 1 over cosine A cosine of B, what will change with the difference. Again, just not everyone has that sort of forward-thinking mind, so that's why it's fun to prove. So let's do it anyway. This entire thing cancels once again, and none of this cancels, so we're good. So now, again, sine of A over cosine of A. This is tangent of A. This is, again, tangent of B. This is 1. And then this is, again, I'm going to rewrite it. Sine of A over cosine of A times sine of B over cosine of B. So this will then be tangent of A times tangent of B. So we can say therefore tangent of A minus B equals to tangent of A minus tangent of B over 1 plus tangent of A tangent of B. So yes, hopefully you notice it's just flip-flopping the signs. That's why it's so beautiful to write it in this way, because the reason why people write the sum formula in sum and difference formulas for tangent in this way, specifically with the multiplying by 1 over cosine A cosine B, is because yes, it is a cleaner form. It's all in terms of tangent. Also, it's easier to remember at the top of your head. Not necessarily, you can memorize wherever you want, but just in terms of remembering, again, if you're under a strict time limit, you just got to know it at the top of your head. Of course, peace of mind that you know where it comes from. You'll just be like, oh yeah, they just flip-flop. This is true for both sine, cosine, and for sine, cosine, and tangent. There's sum and difference formulas, right? It's really just sine flip-flops, and that's why it's really nice to see it in those forms. So yeah, hopefully you enjoyed. See you guys in the next one.